this computer. Okay. Welcome, guys. Thanks for joining the class once again. So, this week we are discussing the linked list data structure, right? And in the previous classes, we have discussed about the overview of linked list, what could be the different basic operations that can be performed on the linked list, and also we have discussed and build the intuition and the visualization. How can you um, do the insert operation at the head, right? In the link list, if you have a head node, so if you wanted a new element at the head position, so how are you going to achieve that one? Correct. So that was the uh, operation we touched upon and we discussed, and we have done the implementation in the last class. Okay, now in this class we are going to look at how the other same operation insert, but let's say if you wanted to add the element at the end of the linked list, how will you achieve that one? Okay, meaning let's say for an example, let's say let's say if you have a this node, if you have a let's say this node, okay, these are the nodes that are connected to each other. Let's say value is 2, 6, 8. Okay, so in this linked list, this is the head position. The first element is pointed by the head node. So this is the head node. And in the previous class, we have discussed and understand how, let's say if a new element value is 8, if you wanted to add this value at the head position, how will you do that one? That is the part we have discussed in the previous class. So far with me, guys? Okay. Now what we are going to discuss about here is, let's say if you wanted to insert this value at the end, how will you do that one? Correct. So now let's visualize this one and build the intuition for this one. So what we are saying here is, insert a new element as the last element of the list. Insert at end means we are going to add a new element as the last element of the list. So that means whatever the element we are going to add, right, their next node will be what? What will be the value of their next node?
Null.
Null. Perfect, Kshitiz. Yeah. So the criteria in the singly linked list is if the last node points to the null, so that means that is the end of the list. Okay. So now visualize this one. Let's say initially your list is empty. Initially your list is empty. What does it means? It means that your head will points to the null. That means your first node, right, that is pointed by the head node will be null. Correct. Now when you say insert one, insert a new element at the last, yeah. So now insert one. See guys, what are we going to discuss? Insert a new element at the end, right? So here, let's say initially if your linked list is empty, initially if your linked list is empty, that means it is as good as you are adding a new element at the head. So far with me? Okay. So now initially when your linked list is empty, your head node will point to null. Correct. Now what are we going to insert? We are going to insert one. What are we going to do here? We are going to insert, hold on a second, what we have discussed, insertion at head. insertion at head we discussed. Okay, perfect. Now, what are we going to do here? We are going to insert the value 1, right? So that means you are going to insert this value as the last element. So now your head points to the value null, and once next node will be null, right? That means it is the end of the list. Correct. 1 become next element of head because initially you don't have any node into the list. So now when we are trying to add insert 1, so that means your head will point to this value, this new node, and the next node of this new node will be null because that is the last node. Now let's say if you have the other use case, let's say if you have already a one element inserted, right? Now if you wanted to insert 2 at the end, correct? So when you are trying to insert 2 at the end, that means this new element next node will be null, correct? So if you look at this one, head is pointing to 1. Now since you are going to add a new element and that new element will be the last element here, so we have added this new element and it points to null, correct? Because what we are talking about, insert at end. So 2 becomes the next element of 1, and next element of 2 becomes the next element of 1, correct? And next element of 2 will be null. So far with me, guys.
Yes.
Yes. Okay, where is Kishan? He left out? Maybe
Yes.
some network issue. Okay, I don't know. Anyway, no worries. Okay, now let's talk about the implementation. It is very straightforward. If you understand the basic concept, whatever I discussed in the previous classes, it will be super easy. Okay. Now, how will you implement this one? Insert at end. So you have a method insert at end and you are passing some data. Some data you need to add at the end of the list. Okay. So if you look at this one, right? Insert at end. So in the first, let's say if your linked list itself is empty, so that means it is as good as adding a new element at the head. So far with me? Okay. So now the first condition what we are checking here is, if you look at this method, inside this method, the condition what I am saying is if the list itself is empty. Okay. If the list is empty, so we already built the method is empty, right? In the previous classes. Correct. This is the helper method. If you go to the previous classes, is empty method. You see here is empty method. We already build it, right? If your head node is null, that means it is empty. Otherwise, it returns false. Guys, are you with me?
Yes.
Okay. Now, what we are saying, if your method is empty, right, that is already we have implemented, then call insert at head. This we also discussed in the previous class. Guys, are you with me? What I said,
Yes.
if your linked list is empty, that means it is as good as adding that element to the head, right? So insert at head, you will just pass the data and return it. So if you look at the insert at head method, insert at head, right? You see insert at head. So here we already discussed this part. So we are just calling this method. We don't need to write this logic again. Okay. We have discussed a lot on this topic. Okay. Now let's move on. So far with me. Now we will talk about the other use case. Okay. So In other use case, let's say for an example, this is the use case where already linked list has some nodes already present. Okay, then in that case, how will you do this one? So this is the way. So remember, when you wanted to add a node or you wanted to delete a node, if you wanted to perform any operation on the node, the very first step is to create the node. Correct. So you have a node class, we created the node, and in the node we assign the data, whatever the data you are passing. This data, I'm talking about this data. This data. Okay, let's say 268. Correct. And if you wanted to insert the value 20, what is the value of the data? That is 20, that I am talking about. Okay. Now, if you see here, there is an extra line here. What it does, this is the logic. So, what are we going to do? What are we doing here? We are adding a new node as the last element of the linked list. So what is the criteria of the last element of the linked list? The criteria of the last element of the linked list is its its next node. Last element's next node will be null. Means after the last element there won't be any node. So that is the reason it points to the null value. So which node you wanted to make as the last node or last element? The new one, right? So that is the reason I'm saying new node dot next node is equal to null. So in memory, if you visualize this one, so let's say if you created a new node, right? So the new node is 40, right? And this line, if you write, so that means it will point to the null. So next node is null because this will be the last node. This will be the last node. So that is the reason this new node's next node pointing, it will be pointing to the null. So far with me, guys? Okay, perfect. Now, what are we going here? See here. Let's say if you talk about this is your node, this is your node, this is your node. Okay, let's say 2, 3, 4. Okay, and then 5 you wanted to add. Where you now this is the null. Okay, hold on a second. This is null. Okay, where do you want to add this element 5? Here at the last. Correct. After this 4. Okay, so now how will you know that where the last element ends? How will you know that? See, what I'm saying is you have a head node. You only know about the head node. Ritik, Kshitish, Kishan, you only know about the head node. Okay. And the criteria is this new node should be added at the end. How will you go to the end? How will you go to the end, last node? So you need to traverse it, right? You need to traverse it. You need to traverse it. Correct. So how will you traverse? So you know the head node, right? So we will just assign in the, you can consider it current node or last node, any node you wanted to named it. Okay. Now, so this is your head node. Okay. And this present this one. When you execute this line, that means last is also pointing to this one. So far with me? Correct. It's the same as, only thing what we have done is we have just creating another variable last so that we can iterate this one. Correct. So what we are checking here is if this current node, next node, if it is not equal to null, then keep on iterating. Keep on iterating. Meaning, let's say 2, 4, 6, and then null. And this is your last node. Okay. So what it is saying? What it is saying? Last node dot next node. Last node, next node of last node is what? This one. Is it null? Is it null? No. No. Condition is true, right? So that means it will go here and this will, and now last node will be pointing to this one. Now similarly, once you reach here, then again check last node dot next is equal to not equal to null, then it will reach here. Right. Now it will go here and again check. Last node, this is your last node. Its next node is null. Yes, it is null. It is null, right? So when it is null, so that means last dot next node is equal to new node. Correct. See, what is the last represent here? 6. Okay. So that means this 6, this node's next node will be the new node. Correct, guys? Now it is pointing null. Okay. Now let's say the element you are adding at 8. Now instead of null, now it will point to 8. That is what we are doing here. And then we increase the size. So make the new node as the next element of the last node. Guys, confusion?
No.
Ritik?
No.
Okay. Shall we move on?
Yes.
Okay. Let's move on. Okay. Now we have, in the insert operation, we have 3 different flavors: insert at head, insert at tail. Now we are going to discuss the last one, insert after. Insert at head means adding as a first element. Insert at last or tail means inserting the new element as the last element of the list. Right. Now insert after, here insert after means what? We are going to add a new element after a certain given element, or after a given element. Meaning, so let's say insert a new node after given node. So for an example, let's say this is your initial node 1, 2, 3, 4. So far with me, guys? And this is your last node and it is pointing to null. So this is your initial list and head is pointing to 1. Okay. Now you need to insert 10 after 3. After 3, you need to insert 10. So what is the new node value? What is the new node value? Kshitiz, what is the new node value? Ritik?
1, 2, 3, 10, 4, null.
What is the new node value you are going to
10.
insert?
10.
10. Where are you going to add this value, new node?
After
After
3.
After which node?
3.
After 3. So what is the use case? After 3, you need to add a new node here, and whose value will be 10. Okay. So to insert 10 after 3, I need to reach that node 3. Correct. So how will you do that? Again, you need to traverse. iterate the list or traverse the list. Correct? So now look at here. So we will do a start. Since you already have the information about the head node, so what are you going to do? You are going to iterate. So here current starts at head and check for the node value 3. Why 3? Because after 3 you need to add this value 10. So here current starts at head and check for node whose value is 3. Okay, so current starts from here. Okay, now in the next step, so you need to check whether this current value is equal to 3. Not found. 1 is not equal to 3, right? So that means current moves to 2. So this current node, it will move to 2, right? Earlier it was pointing here. Earlier it was pointing where? This node here. Now, since it is not equal to 3, condition check and then it will move to 2. Got it, guys? Okay.
Yes.
Okay. Now it will check currents. Now again check whether in the next element, whether this value 3 is equal to 3. 3 found. It got 3. Node value is 3, right? So that means when you got 3, what is the criteria here? You need to add this new node whose value is 10 after 3. After 3. So to add this node, what we need to do? We need to create a new node whose value is 10. So that is what we have done here. So there is a new node whose value is 10 that is created here. So create node 10, next step. Right. Now, when you create a new node, right, who will have the address of this new node? Who will have the address of this new node?
3.
3. So that means earlier 3 is pointing to 4, means 3 has address of 4. Now 3 will have address of 10. Correct? And it will be broken. Link between 3 and 4 will be broken. Correct? Now, so you have added 10 here and the address of 3 points to 10, right? But what about this last element? This, whatever the element, this fourth element. Who will have this address of this 4?
10.
10. So this is the address. It should point to 10. Did you visualize this one? Just visualize this one. You need to add a new element whose value is 10. So when you are adding the new element whose value is 10, so that means the address of the new node will be assigned to 3, because after 3 you need to add. Okay. And the next element, right? Earlier this node was pointing, that will assign to the next node. Basically, the address of this will be assigned to the new node. So 4 will be the next element of, so 4 will be the next element of 10, correct? And 10 will be the next element of 3. 10 will be the next element of 3 and 4 will be the next element of 10. So far with me, guys? Any doubt here? Okay. Let's look at the implementation part here. How will you implement this one? So we have a method called insert after. Okay. So when you say insert after, so that means you need to give the data. You need to give the data, which data you want to add. And also you need to give the previous node where you wanted to add, right? So for an example, in the previous example, 10 was the data, and we also need to, user needs to pass, right, where this 10 should be added, after which value or node, right? So here it was 3, the value was 3, correct? So that means here data is 10 and previous is 3. Got it, guys? So the question will be framed like this one. You have a linked list, add a new element 10, right? Add a new element 10 after the node values 3. Okay. Now, if you look at this visualization, so we need to insert a new node, right? So what is the first thing we are doing? So we will create a new node, correct? Because you only have the data. So with that data, you need to create the what? You need to create the what? New node. So you have created a new node object. Okay. And you assign this data, that means 10 here, new node dot data dot. That means you created a new node, okay, whose value is 10. You created this. At this point, you created this one. Okay. Now we need to traverse the list. That is what we are doing here. Traverse the list. To traverse the list, what do we need to know? We need to know the correct head node. So we already in the linked list class, we already defined the head node, right? If you go to the previous example. So now we'll assign that head node to the current node because we will traverse on the this new this variable. Okay. Now traverse the list until the node having data is equal to this previous. So far with me, guys. Till when you will traverse once you find this 3. Once you found this 3, right, then only you will stop. Okay. So traverse. So how? So now you know that you are here. You know about this head node. This is the head node. So that is what we have the current node here. So current node points to the head node. Now, if your head node or current node is not equal to null and current node dot equals previous, if it is not equal, if it is not equal, correct? If it is not equal, then what we are doing? What are we doing? We are, if it is not equal, then we are moving to the next node. So what we are doing? Current node dot next node. That is what we have done here. If it is not equal, if it 3 is not equal to 1, then your current node moves to the next node. Current node moves to the next node. Okay. So here, if current node is not equal to null and current node is means current node data is not equal to previous node, basically current node dot data, it will be current node dot data. If it is not equal to the previous data, here it will be current node dot data. Not equal to the previous, then we will move to the next node. Correct, guys? So when this loop will be break? When this loop will be break? When this loop will be break? If current node dot data equals previous. Okay. Any doubt, guys?
No.
So when it will break, once you, let's say once you found 3. So 3 equal to 3. Condition is true, but you are making it false. Correct? So let's revisit this one. So what I said, if current node dot data, I think here, so let me correct it. Current node dot data. Okay. Current node dot data not equals to previous, then your current node is equal to current node dot next. Just look, just visualize this one. You got 1. You got 1. What is the current node value? Current node dot data. What is the value here? For this one, what is the value? 1.
1.
1 equal to 3. Is condition true or false?
False.
False. If it is false, you negate it, right? That means it will go inside this one. Correct, guys? And then it will move to the next node. Okay. Now again it will check current node dot data. Now this time your data is 2. 2 equals 3. Is this condition true? No, this condition is false. So again it will come inside because this negate will make it false. True, right? So it will go here. So now once you found 3, so 3 equal to 3. Okay, condition is true, but you making it false. So that means it will not go inside this loop. When it found 3, it will break out this loop. Correct? And here we are checking. If current node is not equal to null, if current node is not equal to null, then what are we going to do here? When you found this 3, when you found this 3, what are we going to do here? This current node, next element, you pointing to the new node. This, when you found this one, so current, this is your current node, right? The next element of this current node will points to the new node. That is what we do. Current node dot next node is equal to current node dot next. Sorry, new node dot next node is equal to current node dot next node, and current node dot next node is equal to new node. Okay, did you get this line? What exactly we are trying to do here? See what I'm saying. What is new node? What is new node here? What is new node? New node is
10.
10. What it says? New node is 10. New nodes, next node. New nodes, new nodes, next node. What will be the new nodes next node? 4. Correct. How will you get 4? Who has the address of 4?
3.
This node,
Correct.
right? So that is the reason we are saying current node dot next node. Ritik, getting it?
Yes.
No, you are not getting it. Are you getting it?
Yes.
Okay, perfect. Now we have assigned this one. What is left? Now look at this one. Current node dot next node. What is the current node? This one. Its next node should be new node. Current node dot next node is a new node. And then you increase the size. You got right? You build the intuition how exactly it is working. Okay. Why are we checking current node is not equal to null? Why are we
To
checking?
check, to verify the list is not empty.
list is not empty. Correct. If it is list is, so think of the use case. Let's say you have an element 1, 2, 3, 4. Let's think this one. You have an element 1, 2, 3, 4, and it points to null. Okay. And you say insert 10 after 9. So 9 no longer exists in this list, right? So that means when it will loop, when it will try to find 9, it will go till end, and at the last it will be null, right? So that means this current node will be null. Correct. That means when your current node is null, that means you didn't find that. Got it, na? So that is the reason you need to check current node is not equal to null. So far with me, guys?
Yes.
Yes.
Okay. Now let's talk about delete operation. Okay, so when we are talking about delete operation, so you can delete at head and you can delete a specific value. Okay, let's say let's say if you have a list, right? Let's say 10, 20, let's say you have a list 10, 20, 30. Okay, and you wanted to delete head. So that means the first element of the list you wanted to delete. Now if I say delete 20, so maybe this is delete by value. Okay, now delete at head means whatever the value you have at the head, delete it. That is the delete operation. So delete at head works by moving the head pointer to the next node, making the original head unreachable and eligible for garbage collector. Okay, let's understand this part. So let's say you have a list 10, 20, and 30, and last node is 30 here. Okay, so 10 is your head node. 10 is your head node. Correct. 10 is your head node. And you wanted to delete this one. So when you delete this one, right? When you delete this one, then where your head node will point?
At 20.
20 here. Okay, that is what we need to do here. So you are saying public void delete at head. So before deleting a head, we are checking this condition if it is empty. If your list itself is empty, then what are you going to delete, right? So that is the condition we are checking. If it is empty, just simply return. You don't have anything to delete. Okay. Now let's say if it is not empty, then in that case, so now head node, what is your head node, guys?
10.
10.
10.
What is the next node of head node? What is the next
20.
node of head node?
20.
20. Right. Once you delete this 10, where your head node will points?
20.
20. So then your head node will be just head node dot next node. Correct. Your head node will be the head node of next node. So when you delete this one, the address of the next node, right, you will assign to this head node. Correct, simple. And then decrease the size. Now let's visualize this one. Let's visualize this one. So let's say in this case, you have a node A, and that is your head node. Okay. And this node, visualize this node, whatever the operations we have implemented, we have visualize this one. You have a node A. So node has two parts, right? Remember in the node class, you have a data part and you have a next part. Next is nothing but it points to the next node, node B. So far with me, guys. And even for node B, you will have the data and it will have next and it will points to the node C. Correct? And then again it will have the data, and here if it is the last element of the list, then this next will be null, right? So all node will have a data and next node address. Visualize this one. Node A points to node B and node B points to node C, and it has two data members: data next, data next, data next. Data is the actual value and next is nothing but a address of the node B, sorry, next node. Okay, guys, so far with me. So this is the
Yes.
way you can think of. Now in this case, at this point, your head node is pointing to node A. Correct, guys? Now when this node will be executed, what is the think? What is the head node, next node? What is this value? What is the value of this line statement? Head node dot next node. So this is your head node dot next node. What it points? Node B. This is your node B, right? This is your node B. What does it mean? Head node dot next node. This is the node B, right? Correct, na? And this node B needs to assign to the head node so that it will be removed. Got it, guys? So at this point it is pointing to this one, so it will break it out and then it will point it here. Okay, I think this is the last. Now delete by value we can cover in the next class. Okay, any doubt, guys, in today's class?
No doubt.
Okay. We'll do all these, whatever we have learned, visualized, done the implementation, right? All these things we will do into the IntelliJ or any editor one by one. Okay. And I will share all these notes and um, this recording to you guys later on. Okay. All right. Thanks for joining once again. Bye bye.